All right, so what happened when limits as x approach to c on b? What do you think is equal to? Now, c and b both are constant. This question, let's see if anybody can figure out. Yes? No. And I'll give you a clue. Should I give you a clue? Think about graphically. They both are constant. Yen should be able to figure this out. Yen, what do you think?
No idea.
Yes, a bit.
Is it B?
Yes. Why is B?
Because if you were to graph it, like f of x would normally be there, so it means b would be y. If y equals to 4, it would just be a straight line, and c can be any constant. If c is any constant, it would be along that line, which would just be b.
Did anybody understand what he's saying?
No.
See, that's why I call you. No, I'm just kidding.
Hey!
I'm just kidding.
Great to cry.
I know, right? No, go to Goldberg. Faster. B, for example, let's say it's y equal to 3. And this 3 is a B, right? So I'm going to say y equal to 3 is right here. Right? So it doesn't matter what C value here. The output is always 3. So basically it's, it's 3, which is B here.
Oh, I get it. Because it's like a constant.
Yeah, it's constant. It doesn't matter which value I reach, right? Which value C or reach is always going to be, output is always 3, regardless of what happened. Very good job of it. Okay, so that's first basic limit. What happened when limit x approach to c of x is equal to what? Don't worry, Krishan's answer was dumber than yours earlier. He said A for the first one. I don't know why'd you come up with the A. By the way, I don't make fun of people I don't like. So I have to like you to make fun of you.
You make fun of me a lot.
I like you.
Krishan doesn't believe me when I said that.
Yeah, x approach c on x. What do you think it's gonna be? What? X is not correct. Ashton? C is correct. So think about an x, right? X graph, right? If you just think about x graph, it's gonna be like something like this, right? X graph is gonna be something like this, right? But if you say it's 1, the output is 1, right? It's 2, the output is 2, right? Even at -1, what's the output? -1. So it has to be C. Then just plug in a value. Just plug in C. Okay, third, the basic limit. A limit x approach to C of x to the n is equal to C to the n. Just plug in. So let's 3 basic limits. Okay, let's go back. Where'd it go? Okay, this. Okay, so I didn't want to rewrite again, but I read it last period. So, which is basically, I'm just gonna go through it. This just means limit x approach c is equal to L. L is, let me explain to you what's L. L is just another number. We like to use number, ABC is a constant. L and K is a constant. So they are all constant. They are constants. Now, when do we use a variable? X, Y, Z usually is a variables. So when we use in like C, this is constant. This L, a capitalized L, that's a constant. This is a K, that's a constant. So if this is true, then you should have following 5 properties. First property is scalar multiple. Scalar multiple is actually probably the only one that's really important here. Is understand that if you have a b constant here, you can take the b out. You can take the b out, outside the limits. So b, if it's here, can be outside the limit. B can move outside about limits. So the b can be moved outside. So you can write down as a b as limit x equals c of f of x. So at the end, it's going to be b times l. But the b can be outside is very, very important limits property for you guys to use. You guys are going to use that a lot. Especially when we deal with trig limits, which is that's going to be on Thursday. Which is that's hard. Now, sum and difference. Sum and difference is actually limit x equals c of f of x plus minus g of x. That's just equal to L plus minus K. But that's very intuitive. If I have limit x equals to f of x and limit f equals to g of x, and they can both add together, the result is going to add together. Same thing on multiplying, dividing, and power. So that's pretty much a reciprocal. So I think the most important one is the first one. That I think that the constant can be taken outside the limits. That's like the most important one. The other one is all pretty intuitive. Now on the fourth one, basically also says k cannot equal to 0. If k equal to 0, it's automatically defined because k is on denominator.
Maybe that's one.
Fourth one's quotient. Okay, so this is very intuitive. I'm just gonna move on because this is very simple. They're not something very complex. I think the most important one is this one. I actually gave a question like this before on the test, and people screw up. Like Kushan will say, put A. I'm like, where did you get A from? Okay. So now we're going to talk about finding limits algebraically. So finding limits algebraically. So the first thing about limits, always plug in the values. Plug in the value. Plug in what value? X approaching 2, then just plug in 2. Okay, if you plug in a value. Now, if you get a value, let's say if you got an answer of 1/2, you're pretty much done. There's no more need to be due. No more. Now, sometimes, Ian, you might want to copy it down because later on you're going to say, I don't understand this. Especially this part is very important. Sometimes you're going to get a 0/0 situation. What's the word for 0/0? Indeterminate. Is not undefined. So indeterminate. Whenever you have 0/0 indeterminate, then you have to resort to 4 different paths. So there is 1, 2, 3, and 4. At least for right now. Later on, there's a 5th one, which is the most important one. But right now, we got 4 things that we can do. And those four things are, if you ever have a 0 over 0, I would just tell people, says do math. Yeah, it's gonna be what kind of math, right? One is factor, and cancel. So hopefully you can factor the numerator, denominator, whatever you can factor using box method or whatever. You can factor and you can cancel. That happened pretty often. That's also the easiest question on the test. Hopefully you know how to factor the cube, the box method, the difference of a square. And if you have negative sign, you have to factor out a negative sign sometimes. That usually help you. 2, if you have a complex fraction, I will combine fractions. And next things I will do is, if you have a radical, I will do a conjugate. You're gonna be like, what is conjugate? If you have absolute value, and we're probably not gonna get to this case, but when you have absolute value, you have to think about definition of absolute value. Which is break down to piecewise function. Piecewise function. So you will get all those 4 choices. Today we're going to talk about all those 4 choices. Now, we probably don't have enough time, but tomorrow we also going to talk about squeeze theorem. And the day tomorrow we also going to talk about when you have number over 0. Number over 0, you're going to do a one-side limits. And one-side limits usually is a plug-in a value that's 0.1 away. And you're going to get a couple results. Those result infinity, negative infinity, or does not exist. So pretty much this is the whole section of the limits. Also, there's some minor things. We're going to talk about intermediate value theorem, remove discontinuity, non-remove discontinuity. We're going to talk about how to make function continuous. We're going to talk about a lot of things, but this is a few cases that you're going to have. So this is like a flow chart. When you're looking at the problem, you should look at this flow chart. If you look at this flow chart, you can understand everything. Now, what happened? We're going to start with the first limit question. X approach 2, 2x squared plus 3. So what's the first thing about limits? Yes. Plug in. We just plug in. And that's going to be 2 times 4 plus 3. And that's going to be 11. And hopefully that's done. But is a chance that I give you this question? It can be, but it's possible to just try to trick you, because I can trick you in different things. This is one of the things that people usually get tricked on. Is the first thing you should always plug in a value. Doesn't matter what, because sometimes you get an answer right away. But majority of the time, that's not going to happen that way, because the majority of the time you are going to get something like this. What happens if I plug in? It's not over 0, it's 0 over 0. If it's 0 over 0, that means you have to do math, right? And it sounds like a very cliche, but it's like, yeah, just do math. What kind of math I can do here? Factor and cancel. So can you factor the x cubed minus a over x minus 2? So remember how to factor the cube? You guys can try it, but I'll give you the formula. So it's a cubed minus b cubed equal to a minus b times a squared plus ab plus b squared is called SOAP. S-O-A-P. So same sign as before, opposite sign as before, always positive, and the last sign. And it's just blood type. A, blood type AA, AB, BB. And if you have a plus b to the cube, that's equal to a plus b times a squared minus ab plus b squared. So it's also SOAP. Can you tell me what do I do next? Limit x approach 2. What's a factor of x cubed minus 8? X minus 2. X minus 2, what else? No. X squared plus 2x plus 4 over x minus 2. So this you can cancel. Now you can plug in 2. Limit x approach 2. So it'll be 2 squared plus 2 times 2 plus 4. That's equal to what? 12. So we did the first possible situation. Okay, so second possible situation. So there's all different kind of factors. There's box method. There is difference of a square, factor out GCF. So all kind of factor counts. Okay, be careful. All kind of factors count. Next thing is what happened when limits x approach to 0 of square root of x plus 1 minus 1 over x. So what's the first thing you have to do? Yes.
By
No.
conjugate?
What is conjugate? When?
Oh, you multiply everything by square root of x plus 1 plus 1.
Very good job. I like that. So you multiply this by square root x plus 1 plus 1. But technically you cannot just do that. What happened to the bottom? It has to be exactly the same thing, right? Why? Because this essentially is the ratio of 1, and that's fine. You rationalize it. You're doing correctly. You cannot multiply by other things because you change the fraction if you do. So limits x approach 0. Now, obviously, you know another equation is a plus b times a minus b is equal to a squared minus b squared. That's called difference of a square. Now, if you have a minus b here, right? If I have a plus b, do you see that? We know it's the top FOIL together is going to be a squared minus b squared. So if a squared is going to be x plus 1 squared minus 1 squared all over x times root x plus 1 plus 1. Now, obviously, you're going to see this is a problem. Why is this a problem? Because if I plug in 0 for x, and 0 times anything is going to be 0. So somehow you're going to get rid of this problem. I'm going to see what happens. Limits as x approach 0. On the top, if it's square, it's going to be x plus 1 minus 1, right? So this is x over x root x, x plus 1 plus 1. This is going to cancel out. That's 1. So it'll be 1 over 2. I might have to redo this video because you're missing the last part of the video. But the last part is just combined fraction. That's actually not that bad. So I'm gonna try to do it again the video on the next period. Make a better video. But you're missing one thing here. So you probably have to watch the last 5 minutes of lecture. But this is a harder one. The other one you can actually do without me teaching you.
Idea.
What?
Like, we made Celsius tolerant. No empty can. Right there.
No. Go away. Bye. It's gonna grow ends.
You don't turn in the homework or anything? We don't turn in
I only look at the homework.
Okay.
If you don't do a homework, you'll fail the test. So you have to
I
do
did.
homework. I know.
I figured out the problem, how to do it, so I'll show you.
Alright, can you show me?
Yeah.
Okay, how about the other side? Oh, that's fine. I put 10 points on it.
Okay, thank you.
But Marshall, make sure you watch the last 5 minutes of lecture. If I post again, the second lecture will post like I will make sure that 5 minutes is included. Bye. Bye.
Happy days, sir.
Me too.
You just saw that.
What train you have?
25. Like the
25? It's okay. We're gonna go over it.
Well, they were like questions. No, we got a bit for it. That's it. Yeah, he got to hear.
Students, 1 minute remaining until class.
Maybe watch
Is it
Wait, close. Test notes.
That's why you gotta be your brother.
My dad's not explaining it. I'm like, I cannot believe it. And then I was talking to him, I was like, I should have never told him I played basketball so I could play him for an A. Like, I should have never told him. Are you serious?
All right, so I don't know who dropped out of the class. Somebody drop out of the class. Let's see who dropped out of the class.
See, it's like
The process like when we
it's a bunch of
be like or it's part of it, right? I was saying like but then I have to plug it in and when I plug it in I have to it was kind of
Okay, so you know how they had the X squared and the 8 minus 2x.
All right, so a couple of things. Omni move. Aiden move up here. Move up here, and Omni move up, and Slater move up there.
Yeah, I need a re-invitation to the group chat. I don't know.
You left.
Probably.
You're like, I can't wait to leave.
Wait, you don't have to. Algebraically.
Omni move to the front. Yeah, move to the front. So that is easier for me to take a type. Somebody obviously not here. I don't know who.
Proceed.
Maya's not here. Maya's not here? All right, so couple of things. Anybody have this extra credit for me? Show me. That's the first thing. Second thing, this is worth 10 points. Now, another thing is, if somebody asks you, says, hey, can I copy it? No, don't help him copy it. Just say, let me help you instead of let you copy it. That's the best response. So, Aiden, actually move your seat over there. So that's my SC, sorry. Yeah. Julia, that's okay. Sit there for now. I'll rechange it later. We're gonna be in group later. After the lemon test, we're gonna be in group. I don't need to test. So if you have this, show me. And if somebody asks you, says, "Can I copy it or can I look at it?" No. Let me help you. That's a proper way to respond to somebody because you gotta make sure you understand them rather than just let people copy it. If you copy it, doesn't understand. Don't go on the math way to do how to do something. Figure out how to do it. And I will show you example that says this. A lot of things that people think that how those are people don't care about like those basic stuff. It's very very important. I'll show you somebody that somebody like from uh,
Oh, great. Is that
Oh,
my mother?
yes. Sorry. Sorry. So no, I want to. That's not sure. Wait, it's not this one. Okay, so here. Okay, so this is one of the student I tutored yesterday. And I'm gonna show you something that's very crucial here. And just to show you like those fundamental technique that if you don't have those basic algebra background, that you're not gonna see what's wrong with it, and you're gonna be doing it, and you think it's okay. So I want you to look at the bottom of the denominator when you multiply top and bottom by 3x. Okay, and you see the bottom, the 3x. So she multiplied 1 over x minus 1 over third times 3x, and then but she got 3x over x minus 3. Is that correct? No. Do you think, what do you think she did? She combined the denominator, which is, you cannot do that.
Oh.
And she did just 1 times 3x on the numerator.